Hi everyone, today we are going to look at 2019 NCEA Level 1 Science, the acids and bases paper. As always, one question per video. Subscribe if you haven't and smash the like button if you find this video helpful. Question 1, so this is a race reaction question. Let's get started. So first one is test tube A contains 0.1 mole per liter nitric acid, tube B contains a more concentrated 1.0 moles per liter. Now, as a year 11, you don't need to know what moles per liter mean. This is just a unit for concentration. The bigger the number, the more concentrated it is. They even told you that this is more concentrated, so that should be no problem there. Now, a piece of marble chip was 0.5 grams, and then they showed you that this particular reaction has more bubbles because you have more concentrated. They even said, see, more concentrated, less concentrated. So if you're not so familiar with the unit, that is okay. That shouldn't hinder your chance of tackling this question. All right, so let's look at this question. So we got calcium carbonate, hydrogen, nitric acid. All right, so word equation. Word equation is only achieved. So this is nitric acid reacting with calcium carbonate. And just a trick with these is that to figure out the salt, the only three acids you need to know is nitric acid, hydrochloric acid, and sulfuric acid. So when nitric acid becomes a salt, it becomes a nitrate. And what nitrate it is? It is the metal part from the base or from the carbonate that you write in first. So it's calcium nitrate. And because you have a carbonate, you make water and you make carbon dioxide. Now, if you are going for myriad excellence, you don't even need to do the word equation if you think that takes too much time. All right, balance the symbol equation. Nitric acid is HNO3. It is quite helpful to write down the word the symbol equation, the word equation, so you can write the symbol right underneath to make sure that you've done this correctly. Now these two things are given. Now we need to do calcium nitrate. If you look on your table lines, calcium is NCEA2 plus, nitrate is NO3 minus. So this is a 2 plus charge, this is a 1 minus charge, so you need to make sure the two things have a equal but opposite charge. That's why I wrote another NA3 2 minus, because this will give me a combination of -2 and Ca has a positive 2. So this will be Ca NO3 2, and as you can see, I need a bracket here to indicate I've got 2 NO3 per 1 calcium. Water is H2O, calcium carbon dioxide is CO2. So if you've done it like this, you got merit. How do we get the excellence? Is to balance, and my way of balancing equations is what I tend to say. I just suggest you to start with the unique element, so not your hydrogens, not your oxygens. Start with the calcium, so that's 1 Ca, that's 1 Ca, so that's 1 each, so that's balance. You look at your NO3. I look at this as a group, so this is 1 NO3 and this is 2 NO3, as you can see here. So we need to put a big number 2 in front of the HNO3, and that will balance it. Now if you continue with the rest, because we have got an extra because we've got excuse me, pen's other way around, because we changed the 2 hydrogen, sorry, we'll put the 2 in front of the HNO3, I effectively change the number of hydrogens. So now I have 2 hydrogens on the left hand side, I've got 2 hydrogens on the right hand side, so that's actually perfect. So this is a balanced equation, and that will give you excellence tech for this particular balancing equation. Now next part, explain the effect of using a high concentration of nitric acid on the rate of reaction compared to using a low concentration. Okay, so this, just remember, a higher concentration means this. A higher concentration this means you have more HNO3 particles per unit volume. So what it means is that in the same amount of volume, you have more particles. And if you got more particles per unit volume, that means they're more likely to collide with the calcium carbonate. And that will result in more collisions per unit time. Per unit times, or you can say a higher frequency of collision, and that will result in more effective collision per unit time. More effective collision per unit time. Per unit time, and that will result in more products being produced over time, and that is a higher rate of reaction. Okay, so that's the first part. Let's have a look at the answers. So when you have more concentrated, I just wrote it down in that flow chart because it just always works like that quite well. More concentrated acid, there's more nitric acid particle in this per unit volume. Because there are more particles, more available to collide, there are more to collide, more successful collision per unit time, and therefore a higher rate of reaction. So that is an excellent question as well. Okay, very standard rates of reaction question. And let's get into the next one. So the next one is temperature. So they just asking you to do the same thing, effective increasing temperature. Now temperature has, the question has two folds with temperature. So if you increase temperature at 40 degrees versus 20 degrees, at 40 degrees, you're gonna, when you have increased temperature, that means the particles have more, all the reactant particles have more kinetic energy because the heat energy has been converted to kinetic energy. When they have more kinetic energy, that means they will move around more. And when they move around more, they're more likely to collide. And as a result, more higher number of collisions, more collisions per unit time, because they're simply more likely to going to bump into each other, because that's what higher temperature does. More collisions per unit time. Now, if you just talk about this and you say this therefore higher rate of reaction, then that is going to be merit, because you only talked about one factor. Temperature is the hardest question because this is two factors. You always need to talk about two factors. The first one always people get because they move around more likely to collide, therefore more collision per unit time. You need to remember this, because they have more kinetic energy, a higher proportion of these collisions, remember they need to collide with sufficient amount of energy. Higher proportion of these collisions will collide with sufficient amount of energy, or enough energy, doesn't matter. Vocabulary is not important here. Sufficient amount of energy. Okay, so that means, if we go back here, that means there will be more effective collision per unit time, therefore a higher rate of reaction per unit time. Okay, so temperature is often the question that always comes up because this is the most difficult one. But remember, you need to have two things you need to talk about. One thing is that they move faster. Okay, so therefore there will be more collisions per unit time. The second thing is that there's more energy, so they will collide with more energy. So a higher proportion of these collisions will collide with sufficient amount of energy, and they will result in a successful collision. Okay, so let's just quickly have a look here. Temperature of the thing increases, particle move faster, have more kinetic energy, more collision per unit time. Therefore, due to higher speed or more energy, we prefer to use energy or more speed or more force. As year 11 doesn't matter, but as year 12 it would. But in year 11, just higher speed, higher force, higher energy, they all count. More of these collisions have enough energy, therefore cause more successful collision per unit time or per second. That's fine. Therefore, the rate of reaction will be quicker. Okay, so that's the end of question one. Very, very standard sort of questions on rate of reaction. I personally, if you're someone that's just want to get a merit, I wouldn't advise you spending like hours and hours just trying to balance the equation. That's only worth one excellence point. If you can't balance it, you're already sitting on merit anyway. I would strongly recommend you to utilize your time, focus on the rates reaction stuff, focus on the ion stuff, which we'll do next, because that'll be far more beneficial and more efficient with your time. Okay, so hopefully you found this video helpful, and I'll see you guys next time. Bye bye.